Okay, let's get started. So I would like to welcome you guys to Web8 Speaks webinar series. So before we continue, I would like to ask you guys to raise your hand in Zoom software. This way I can verify you can hear me. Thank you, appreciate it. Okay, so my name is Faheem. I'm with Web8 Solutions. I'll be covering this particular session. So today's agenda is we will discuss how we can deploy applications to Kubernetes and how we can work with logs. And agenda-wise, we will discuss what exactly a microservice is. So first of all, I'll give you a quick overview of microservices. After that, we will discuss how we can utilize Docker container concept to create a small microservice. And once we have created the Docker container, or actually we will have multiple Docker containers, we will see how we can utilize Kubernetes. So first of all, we will have conceptual overview of what exactly Kubernetes is. And then after that, we will discuss how we can deploy a microservices sort of application to Kubernetes. So microservices, if you guys are already familiar with it, well and good. If not, I'll give you overview of it in just a bit. It's usually composed of multiple small containers, and each container will host one small microservice. So basically, we will see how we can deploy a multi-container application to Kubernetes. So multi-container would mean that you will have multiple small services, microservices basically, and we will see how we can deploy those services and how we can ensure that the services are able to communicate with each other and so on. And then we will discuss how we can monitor our applications that we have deployed to Kubernetes, or even if they are just residing in some Docker container, you can still monitor them. For that, we will utilize Prometheus. It's something that you can use even without Kubernetes and Docker container as well. But if you do use microservices concept, the modern way of developing microservices application is to containerize them. So we do create Docker container, and we also try to use Kubernetes as well. So we will have Prometheus running in a separate Docker container, and usually we also call it a Sidecar container. I'll discuss what exactly Sidecar is in detail later on. But generally speaking, when you have a microservices application, each container will contain your actual application or part of your actual application, and on top of it, you'll want to have some side services, something that should be available to all most of your containers. So Prometheus will be one of the sidecar containers, which will be utilized by multiple containers. Then after that, we will discuss how we can use Jaeger to implement tracing. So tracing, if you guys are already developing REST services, you must have noticed that sometimes you have the requirement to keep track of what services got called, when exactly they got called, what was the sequence, like if a microservice calls some other microservice, then what's the overall flow or the sequence in which the services are executed. So if you want to trace your services, for that, you can choose to utilize Jaeger. It's one of the open source options. Otherwise, you can choose to use various other options as well, such as Netflix has various options. Likewise, there is Zool, etc. as well, and so on. So there are quite a few options available. And lastly, we will discuss how we can implement logging, or how we can maintain logs that we have for each and every container by using FluentD and ELK. Why do we have to use FluentD? What exactly is ELK? I'll talk about that once we reach this particular topic. So that's basically today's agenda. Okay, we'll provide you the slides later on at the end of the session. Otherwise, you might have a link to it in the chat window. If not, don't worry about it. We'll provide you with the slides later on as well. Otherwise, I think you do have a link in the chat window of this Zoom software. So you can click on this link. It will let you download a zip file. It contains the slides, etc. and so on. And on my side, I'll show you some extra content as well. You'll be able to watch this webinar later on as well because it's getting recorded. So you'll be able to go through the video later on as well. So, and I'll try to keep things as practical as possible. Where necessary, I'll show you sort of a live demo, and where it's a very time-consuming, I'll show you some pre-recorded videos. So I basically spent quite a bit of time in creating some demos. I recorded the videos for that because some of the steps, they are very time-consuming. So rather than showing you everything in live manner, I'll show you some pre-recorded videos as well, so that we can speed things up a bit. Okay, so keeping this in mind, let's first of all discuss microservices. And actually, before we discuss what exactly microservices is, I'd like to ask you guys a few questions. Like, do you guys already have microservices architecture in place? And do you guys have Docker and Kubernetes in place as well? So you can just answer yes or no in the chat window. So question number one is, do you have microservices architecture implemented? And do you also have Docker and Kubernetes as well? And I'll mention course numbers at the end of the session. There are quite a few courses available for these concepts. Okay, quite a few of you guys are already using Docker and Kubernetes, so that's good. Some of you are using it in on-premises. Some of you are using it on Azure or some cloud solution. So here I'll mostly focus on on-premises implementation of Docker and Kubernetes, but the similar concepts will be applicable even if you're using Kubernetes on Azure or AWS Cloud or somewhere else as well and so on. We do have various flavors of courses available, like some of them are for on-premises version of Docker and Kubernetes, some of them are for Microsoft Azure, some of them are for Amazon AWS, even for GCP, Google Cloud Platform as well. We have some courses available and so on. I'll mention some course numbers at the end of the session. Okay, so some of you are using Docker Container and Kubernetes, some of you are not using it. Okay, so first of all, let's start off with what exactly microservices concept is. So back in the day, a typical enterprise application used to be developed like this. So we used to have some database server. So on the right-hand side, we have database. Let me actually just enter it here. So we have a database server here, and then we have our application server, or it can be a simple web server as well, where we have our application running. So here in this case, we are taking Tomcat as an example. Here we have deployed our application. It's a WAR file. It contains everything. It contains the user interface, which means HTML, JavaScript, etc., and so on. It also contains all the services as well and so on. So you basically have the whole thing deployed in the form of, let's say, servlets, etc., and so on. You're not even using Spring Boot. You're using very legacy way of deploying your application. So you have sort of a single application server or a single web server that hosts everything. So if you have a huge application like, let's say, enterprise resource planning, ERP type of project, which is composed of multiple sub-projects like sales, marketing, inventory, general ledger, payroll, accounts, and so on. In classical or a classic traditional enterprise approach, we used to deploy all of them on a single application server. So it has quite a few drawbacks, like maintainability will be one of the drawbacks. Like if you have to, let's say, maintain one of these services, you might have to shut down the whole thing. Or if you have to update or upgrade your Tomcat instance, you will have to basically ensure that nothing is running at all. So there are lots of drawbacks if you host everything on a single server. Likewise, if the server crashes, then unless you have load balancing implemented, automatic failover implemented by using multiple servers, etc., and so on, you won't be able to access your services if this entire instance has crashed. So you can definitely use load balancer on top of it if you want, but in typical application development, we used to have this sort of structure where we have everything deployed on a single server, and we We have very few WAR files and so on. Like in this case, we currently have just a single WAR file, which contains catalog service, order service, customer service, etc., and so on. Whereas when you use microservices architecture, we change our approach. So in case of microservices architecture, you will break down your application into multiple small projects. Like you have account, product, cart, order in this particular scenario. Or if you have ERP, you will have inventory, payroll, general ledger, sales, marketing, etc., and so on. They will be separate components. And each component will be basically composed of your REST services. Like you will have REST services just for account portion, REST services just for product catalog portion of your application, and so on and so forth. And you will deploy account service. You will consider this as a small microservice, and you will deploy it separately. So it can potentially have its own separate web server or application server. Like if you are using Spring Boot sort of application, or .NET Core, or any modern approach is being utilized, then you must have noticed that you have the ability to start up your application in a standalone manner. Like Spring Boot has its own built-in server. You don't need to deploy it on any other web server, etc. at all. It has its own built-in server. And where exactly we should run that server? So usually we containerize our application. So if you have, let's say, this account service, it will be containerized. Product catalog will be running in a separate container. And what exactly is a container? I'll talk about that in detail in just a bit when we discuss what exactly Docker is. I'll show you how we can create Docker containers, and now we will discuss how we can deploy multiple containers to Kubernetes, and how we can implement logging, monitoring, tracing, etc., and so on. So basically, all these services will be hosted in a separate container. So they will be isolated from each other. If you shut down one of them, it will not crash or fail any other service. Sure, there will be some dependency, like maybe product catalog relies on order or vice versa. So definitely that can happen. But overall, most of the services will still be up and running. So it's not that if one instance has crashed, if one service has crashed, then the rest of the services will not be functional at all. So that won't be the case in this case. So basically, you will have multiple small services, like if you have sales, marketing, general ledger, payroll, accounts, inventory, etc., and so on. They will be separate microservices basically. And database-wise, although you can choose to containerize your database as well, you can have it part of this particular Docker container, but usually we don't do it like that. We keep the database outside a container, because later on when we discuss Docker container, you will notice that containers are expendable. You can choose to destroy them and recreate them whenever you want. So obviously you'll not want to lose any data at all. So usually to ensure that we do not lose any data, we keep the data outside all these containers. So usually in Docker container, we have something called shared volume. The shared volume lets us store the data outside the Docker container. So this way, if you have to destroy your container, you will not lose any data at all. You can always reattach a volume to a new container. It will be able to access the exact same data. So in short, in case of microservices, all these components will be loosely coupled, and they will communicate with each other by using REST services, etc., and so on. So you will have the endpoints, the service endpoints, and that's how they will be able to communicate with each other. And keeping this in mind, let's discuss some of the benefits you will get if you do use microservices architecture. So if you use microservices architecture instead of using the traditional enterprise or traditional monolithic architecture, here, in case of microservices, your applications will be more distributed. Like each service can be located on a different machine. They don't have to be co-located anymore. They can be pretty much anywhere. Like this could be running on your local machine. This could be deployed to Microsoft Azure. This could be deployed to Amazon AWS. This could be deployed to Google Cloud Platform. and they will still be able to communicate with each other. So basically, this is one of the major benefits you get out of microservices architecture. And another benefit is that since these are separate services, separate components, so you can choose to use different technology for each component. Like this could be written in Java. You could use Spring Boot here. This could be written in .NET Core. This could be written in .NET Framework, the legacy .NET. This could be written in Python, and so on and so forth. So you can choose to use a different technology for each component, basically. So basically, microservices architecture, it does have lots of benefits. We do have detailed courses on microservices where we cover the architectural design practices and so on. But here, I just wanted to give you a quick overview of what is microservices so that we can appreciate Docker container and Kubernetes. Okay, so any questions regarding microservices concept before we discuss what is Docker, how do you create Docker containers? And after that, we'll discuss how to create or how to deploy a multi-container application to Docker or to Kubernetes. Okay, so there's no question so far. And before I continue, let me actually give you a quick overview of this one as well. So later on, once we are done discussing Docker and Kubernetes, I'll deploy a multi-container application. So we will have 3 small services. So here we have used microservices architecture. We will have a service which will be responsible for authenticating a user. We will have another service which will be responsible for connecting to or retrieving some data. Like you could have some database, you could perform insert, update, delete sort of operations and so on. And the database will be backed up by this particular service. So this REST service will be able to communicate or connect to the database and perform insert, update, delete operations and so on. So basically we have 2 microservices here, and they are essentially REST services in this case. And we also have this client-side application or the front-end application. It's a React client. I've developed the application by using React framework. So all these will be running in separate containers. So these are microservices sort of applications, and they will be running in separate containers. So a React application will, first of all, connect to this Authentication API or REST API. It will obtain a token. So basically, you can choose to use JWT, JWT, which is JSON Web Token, or you can choose to use OAuth. It's up to you what authentication technique you want to use. So basically, this client application will receive a token from this authentication service. And after that, it will send a request to this data service, and it will add or send the token which it has received from this authentication API. And internally, it will this data API will communicate with authentication API to verify that the token that has been received by the client is a valid token or not, and so on. So basically, we have a fairly straightforward application, but we do have this microservices architecture in place here. So we have 3 small or 2 REST services and 1 front-end application is there in this particular scenario. So later on, I'll discuss how we can build this particular setup, not exactly from scratch. Like I'll not talk about how to write the code for this authentication API and for data API. I already have the projects pre-created. I'll just show you how we can create Docker containers for these applications. How do we deploy the containers to Kubernetes? And then we will see how we can implement logging, tracing, and monitoring, and so on. Okay, so keeping this microservices architecture in mind, that we can have multiple small services, and we can also have our front-end application that can communicate with the REST services and so on. Let's discuss Docker in detail, since that's pretty much the backbone of most microservices architecture-based applications. So what exactly is Docker? So those guys who are already familiar with Docker, well and good. Those who aren't, let me give you a quick overview of Docker. Then I'll show you how we can use Docker practically. So Docker is totally open source solution that works on your on-premises environment. It also works on Microsoft Azure Cloud. It also runs on Amazon AWS and also on Google Cloud Platform and so on. So it can basically run pretty much anywhere. And the main benefit you get out of Docker is you get to create portable applications that you can deploy pretty much anywhere and expect it to work as it is. So it's a portable application. You develop it once, you containerize your application, then it can run on your on-premises environment or on Microsoft Azure or Amazon AWS or Google Cloud Platform or even OpenStack and other options and so on. So it's basically a portable solution. And you can make pretty much any type of application portable. So usually when we develop applications, we have to make sure that we have some physical machine available to us. And then usually we have, or in most cases, we do use some virtualization solution, like a VMware, Hyper-V, VirtualBox, etc. and so on. Otherwise, it's up to you. You can choose to skip virtualization altogether. And then on top of virtualization, you will basically end up installing some operating system like Windows, Mac, or not exactly Mac, but Windows or Linux, etc. and so on. And then you will have to install your runtime environments like JDK, .NET Framework, Python, etc. and so on. And then you will install some application server or a web server. You can skip this altogether if you're using Spring Boot because Spring Boot already has its own built-in server. Likewise, .NET Core also has its own built-in server as well and so on. And then after that, you get to deploy your actual application. So your application runs on top of some server that can be a built-in server, like in case of Spring Boot, or it can be JBoss or WebLogic or WebSphere sort of server that runs on top of some runtime or requires some runtime. So runtime is sort of a dependency. This has to be installed on top of some operating system and so on. So if you use this stack to develop and deploy your applications, you are tightly coupling your application to that system. So your application is not portable. You cannot easily migrate your application to some other environment, especially to cloud. So if you want to make sure that you're able to deploy or migrate your application with ease, we need to create a portable application, a container-based application. And a container-based application will basically ensure that these things, the application itself, your server, like in case of Spring Boot, usually the server is already built in, and your runtime. So these should be self-contained. They should be all available to us. We should not have to worry about, do we need to copy some file from Windows system folder or from C:program files folder. So basically your files will not be scattered. They will all be contained in a single folder, sort of a single folder, not exactly a single folder, but it's very much similar to it. So basically your entire application and all the dependencies that are required to run your application will be contained in your Docker container. And you can take this Docker container and ship it pretty much anywhere. So you can build your application and ship it anywhere you want, run it wherever you want. So that's basically the main concept. And if you use Docker container in your on-premises environment, it's very straightforward to migrate your application to cloud. Like Microsoft Azure, Amazon AWS, they all support Docker container natively. So basically your application will become a cloud native application if you use this particular approach. So keeping this concept in mind that Docker container lets you create a portable application that contains all the dependencies. Let's see some of the core basics of Docker. I'll show you some basic commands like how we can use Docker to create a simple container. After that, I'll discuss how we can build this particular application. So we, if you recall, I mentioned that we have 3 microservices here. So I'll later on show you practically how we can build our microservices-based application that will be composed of 3 separate containers, and we will deploy these containers to Kubernetes. So before we see how to build this semi-complex application that contains multiple containers, first of all, let's see how we can create a very simple Docker container. So for that, let me show you some of these things practically. Some of these commands are already there in the PDF file as well that you guys already have. If you have checked your chat section of the Zoom software, you already have the PDF file there. So basically, you can use Docker command line tool to create your images or the templates for your containers, and then you can later on deploy your Docker container to Kubernetes and so on. So let's see some of the core basics of Docker first. Okay, in the process, I lost my Windows operating system license when I had to reboot the machine. So please ignore this message. Okay, so let me start up my Docker service. Currently, I'm using Windows here, but definitely you can choose to run Docker on Linux, even on Mac as well. And the commands run as it is. So you won't have to change the commands when it comes to creating your custom Docker image or creating your Docker containers, etc. and so on. So while it's starting up Docker service on my machine, again, the difference between Docker image and Docker container is that image is the blueprint. It's your template. You have to specify exactly what tools you want to have or you want to utilize. And then when you run your image, that is basically known as a container. So creating an instance or a running process of that image is known as a container. So container is nothing but just the execution of that image. And based on the same image, you can create multiple instances. So you can have multiple identical containers running based on the same image. And why you'd want to have multiple identical containers based on the same image? For the sake of load balancing and auto failover. So I'll talk about that in more detail in just a bit. I'm just waiting for my Docker service to start up. So it does take a bit of time to start up our Docker service, but after that it speeds up. So initially I'll just show you some basic commands. After that I'll show you actual sort of production-oriented commands that you'll want to use in order to build your microservices sort of application. Like in this case, I have 3 microservices. So I'll show you how we can build the containers in a more professional manner and so on. But initially, I'll just show you some basic commands. Okay, so Docker service has started up. So in order to use Docker, you have to use Docker command. So you can use Docker images. It will show you how many base images or templates you already have. So on my machine, I do have quite a few base images or templates available. Like I have .NET Core image. I also have Ubuntu Linux-based image. I actually also have Jenkins running in a containerized manner as well on my machine. So you can have various images depending on what exactly you want to accomplish. Here, let me show you, or it's already showing up here. So notice that I do have a base image called Ubuntu here. So you need some base image first. And where exactly you can obtain these base images? You have to obtain these base images from Docker Registry. And the default Docker registry that we get to access is available here. You have to go to hub.docker.com website. It's the default Docker registry. So Docker registry means it's a registry. That's where all the important Docker images are registered. So if I go to, let's say, hub.docker.com website, it's the default Docker registry. Here we can see lots of free to use. Most of them are open source based technologies, and you can see you can search for them here. So for example, if you want to use Ubuntu as the base image, or let's say if interested in Ubuntu, you can search for CentOS, or you can search for Red Hat as well. You can search for Ubuntu. You can search for even Windows as well. So even Windows can run in a Docker container as well. So basically, we have lots of base images available here. So for now, let's just keep it a bit simple. I already have Ubuntu Docker image downloaded on my machine. It's one of the smallest ones. So that's why I'm going to use this one. So you can say that we are going to use Ubuntu as the base operating system, and we will deploy our applications here, or we will use it for development or building our applications as well, and so on. So depending on what image you want to use, just search for it. After that, click on it, and it will show you the command here that you have to execute in order to download the image on your local machine. So you have to use docker pull command. You can see various versions of this image here. So if you go to, let's say, tags, it will show you various versions here of Ubuntu. Again, you don't have to use Ubuntu. You can choose to use Red Hat, CentOS if you want, and we can see various versions here. Most of these versions, they have some code name like lineal, etc., and so on, and they also have the version number as well, like 12.08, 16.04, etc., and so on. So on my machine, I already have Ubuntu. Currently, I'm using version 12.04 just so that I can utilize one of the smallest possible images. Otherwise, you can go for the newest version of Ubuntu as well. So this one is just 104 megabyte in size. So keeping this in mind, let's see how we can connect or create a container based on this particular Docker image. So we already have Docker, or actually, let me just quickly review this Docker pull command as well. So whatever base image you have identified on this hub.docker.com website, you can choose to download it by using docker pull command. You can also specify some version number as well if you want. I already have 12.04, but if there's a new update available, it will download that as well. So it's already up to date. Otherwise, you can choose to specify a different version if you want. I won't bother downloading the entire image. It does take a bit of time, like 5 to 6 minutes or so. So just to show you that, yes, you can download more images. I've exited this command, but I'll cancel it out. So basically, you can download some base image. So you can say that our microservice application will utilize Java. It also needs Gradle or Maven to build our application. It needs Spring Boot. It needs Git. It needs some other technology as well, and so on. So you need to connect to this particular image. Or in other words, you need to create a container based on this image, and you need to customize this container. So you need to install your development tools or other dependencies, etc., and so on. So for that, you have to use docker command. So docker run. You can give your container a name. So let's say we call it my dev, and then you can specify the base image, which is this particular image template, Ubuntu. Specify the version as well. If you don't specify the version, it tries to use latest version. And if latest version is not installed on your local machine, it will connect to this Docker registry or hub.docker.com website and download the latest version, which we don't want. So here we are specifying the exact tag so that it uses this image, which is already available on this machine. And then in order to connect to this particular container, which is getting created here because of this docker run command, here, let's say we use bin bash command. So basically, this command will be executed inside the container based on this Ubuntu image. So, and notice that I'm using Windows here. So I have Windows operating system here. This is not Linux. But I have the ability to download Linux-based Docker images on top of Windows, and I can create containers based on that, and I can run all Linux-based commands. So that's exactly what I'm doing here. So this will basically end up creating, I need to specify 2 dashes here for name. So this will basically end up creating a container based on Ubuntu image. And notice that it took barely a second or so to create a container based on the image. So unlike virtual machines, Docker container is super fast. So it barely took to start up a full-blown Linux environment on top of Linux, or on top of Windows in this case. So we are connected to a Linux-based container. By default, it uses a root account. You can always customize the user accounts, etc., and so on, which I'll not bother doing here. So here we can see that it's a full-blown Linux environment. You can execute every possible Linux command here. You can execute apt-get. You can update your operating system. You can install Git. You can install JDK, etc., and so on. You can install Git as well, Gradle, Maven, etc., and so on by using the regular apt-get or yum sort of commands and so on. So basically, you can execute every possible Linux command here. So basically, you'll be responsible for customizing this particular container, update your operating system, install your development tools like JDK, etc., and so on, and then you'll be responsible for saving this image as, or this container as a custom image. So basically, you can see that we can connect to a container based on some image. We can customize it, and then you can exit out. It will go back to your host operating system. You can verify that we have a container running here. You can use docker ps-a command. Notice that we have this mydev container. And if you want to connect to this container again, you can use docker attach command, mydev. It will reconnect to this particular container. But before that, you have to make sure the container is up and running. Let's start up the container and then attach. So basically, we are reconnected to this particular container, which is based on Ubuntu flavor of Linux. And you can again execute all your Linux-based commands and so on. So basically, you can install all your development tools like JDK, Spring Boot, etc., and so on here. And then once you're done, you can save your container as a custom image. So for that, you can use docker commit command, specify what name you want to assign to it. So let's say we call it sales dev version 1, and specify the name of your custom container. So we basically want to save this particular container as this particular image. Docker commit. This is always the other way around. Okay, so we have saved our customized container as a new image. So our image name is sales dev. So in future, you can always use a sales dev. You can verify it here, Docker images, sales dev. So you can see that we have a custom image now. So its size is 142 megabyte in size. And here we are assuming that it already has all the development tools like JDK, Maven, Gradle, etc., and so on. So basically, you can execute these commands to interact with Docker. But do we do it like this in real world? Not really. So here I just wanted to show you some of the core basics of Docker before I jump into more real world way of developing Docker images and Docker containers. So usually in real world, we create a script that should do all these things for us. It should download some base image. It should create a container based on that base image. It should install the development tools for us. It should copy some files as well from our host machine into our Docker image, and then save it as a new custom image. So we usually try to automate this entire process. And for that, we create a script, and that's usually Docker file script. So Docker file script wise, let me give you a quick overview of it here before I show you a more real world way of writing the script. So for now, let me just go to my sample application here. So here I have this Docker file. If I show you the contents of this particular Docker file, so this will basically use this as the base image. Then it will create a container based on this base image, update the operating system inside the image or the container, install JDK. It's up to you what version of JDK you want to install. And then after that, it will also copy a file from our host machine into our custom image. So basically, we want to copy a simple jar file into our into our custom image. So this is the sort of script that we usually write. And to run this particular script, that should use this as a base image, update the operating system, install the development tools, and copy some files into the base image, and so on. We use Docker build command. So Docker build, and then specify what new image you want to create. So let's say I'll just name it inventory this time around. We want to use, let's say, version 1 as a tag, and dot means in the current folder, it should find a file named Docker file, and it should execute that particular script. So Docker build command is used to run or create a custom image. So you can see that it was sort of automated in a sense that we just had to execute this command and everything else got executed automatically. So it ended up using this as the base image. It customized it by updating the operating system. It installed the development tools like JDK. I already have JDK pre-downloaded in my on my machine, so that's why it was fairly fast. Otherwise, when you do things from scratch, it does take a bit of time, like at least 3 to 4 minutes will be required for the overall process and so on. So basically, it ended up creating a new custom image for us, and its name is inventory. So let's verify we have inventory. So we have this inventory image available here. So here we are assuming that we already have our development tools or the runtimes installed, like JDK is installed, and it has also copied over this jar file or a simple Java application into a Docker image. So currently I'm just using the /root folder where I've copied the file. So let's verify that it does contain Java, it does contain our application. So for that, we can use Docker command again. So Docker run, let's give it a name. So let's say test greeting app. That's the name of our custom container. And then now we are going to specify the image name here. It's image template, inventory, version 1. That's the tag which we have assigned to our custom image. So basically, we want to create a new container based on our custom image, which already has JDK, and it also has our custom application deployed into it. And let's use bin bash so we can connect to it. So it barely took about a couple of seconds or so. We have a full-blown Linux environment or Linux-based container here. It's already customized. It already contains our application. Let's verify. So let's use ls-al root. So we have simple greeting.jar file. So this is inside the container. And we copied the jar file from our host machine into our container. So basically, we have a custom image running. So keeping this concept in mind, that usually we use Docker file script to create our Docker image, which contains all the development tools or the runtimes basically, and our custom application and so on. Next, I'll discuss how we can create multiple Docker containers or Docker images, where one Docker image will contain this REST service, second will contain our data service, which will be responsible for returning some data, etc., and so on, and the third will be our front-end application. So we'll basically end up creating 3 separate projects. Each project will have its own Docker file. And then after that, our next goal will be to deploy our application to Kubernetes. So before that, any questions so far regarding this part? Okay, then let's take a short break. Let's resume at exactly 12 o'clock Eastern. After that, I'll talk about how we can build multiple Docker images and how we can deploy them to Kubernetes and how to implement logging, etc., and so on. So let's take a break and resume at 12 Eastern. Okay, so before the break, we discussed what is microservices architecture. We discussed that it's composed of multiple small services, and a service basically means that it's not just or it's not always a REST service. Like it can be a front-end application as well. So we call it a service because it's providing some functionality. Like it's in this case, this service is providing us with the authentication functionality. This is providing us with the front-end functionality and so on. So it is service in that regards, basically. So it's a microservices architecture sort of application. And then we also discussed that Docker can be used to create a containerized or portable application which contains all the dependencies, like the runtimes and all the other dependencies. They're already there in the Docker container. Uh, we discussed some basic commands, like how we can use Docker from the command prompt to create a container, customize it, save it as a custom image, and so on. Then I also showed you how we can use Docker file as well. Then next, before we see how we can build our microservices application practically, let's cover one more topic so we can combine these two concepts together and see these practically. So next, let's talk about Kubernetes as well. So in the slides or in the handout that you guys have, chapter number 2 is about Kubernetes. So here I'm just going to give you a quick overview of it. In the full-blown courses, we cover all these concepts in much more detail. Obviously, here we have a fairly short session, and we have to squeeze in quite a few things or concepts here. Okay, so chapter number 2 is about Kubernetes. What exactly is Kubernetes? Or what's the relationship between Docker container and microservices and Kubernetes? So Kubernetes takes Docker container concept to next level. So Docker container, it's a single standalone portable sort of container that contains your application. And if you're working on a complex application, you will end up creating multiple small containers. Like even in this case, which I'm going to show you practically in just a bit, we have 3 small containers. And sure, you can use Docker, Docker file script to create these containers, which we will do in just a bit. But after that, how do you manage these containers? And what exactly the meaning of management of containers? So management or orchestration of containers means lots of things. So orchestration or management wise, we basically want to be able to make sure that these containers are able to communicate with each other. So we need to make sure that the service endpoints, they are exposed. They should be available to other containers. So let me write down here. So basically we want to expose our services, or it's also known as service discovery. So we want to make sure that the services are discoverable. We also want to make sure that there is load balancing as well. Currently, there's no load balancing here, but we will see it practically in just a bit. So load balancing means that what if you have way too many users trying to connect to your front end? And you need to make sure that they're all authenticated, they're all able to connect to your data service, they're able to perform insert, update data operations, and so on. So how do you handle load? So load-wise, when you use Kubernetes, it allows you to scale out your application. So scaling out your application means that you will end up having multiple identical containers. So your React client, your authentication service, your data service, they can all be scaled out. So you will have multiple identical instances running, and Kubernetes will detect how much load is there on a specific container. If it's already heavily loaded, it will redirect the traffic to some alternate container which is hosting the exact same service. So this way there will be load balancing in place. So load balancing is also offered by Kubernetes. It also offers auto failover as well, which means that if you have multiple identical instances of each container, and if one of the containers has crashed, then it's perfectly fine. Your business will not be disrupted. It will all the services will be up and running, because we have multiple identical instances of each container available. So basically, the moment a specific container crashes, Kubernetes will make sure that it redirects the traffic to some alternate container that has the exact same service running. And actually, it's not just auto failover. It's much more than that. It is self-healing. So self-healing takes auto failover to next level. Auto failover means the instance that crashed, it's gone. You cannot do anything about that anymore. Yes, you have redirected the traffic to some other container, but in case of just auto failover, the crashed instance will not be recovered. Whereas in case of self-healing, it will heal the container. Whatever container crashed, it will actually make sure that it's reinitialized. So it will not fix the exact same container, but it will create another identical container. So it will make sure that you always have identical number of containers up and running at all times. So there is self-healing capability basically. So these are some of the core features that are offered by Kubernetes. Self-healing, it will make sure that you always have the exact same number of containers running, and load balancing will be there, service discovery will be there, and so on. And in case of Kubernetes, we use some terms. We should be aware of just the high-level terms at least for now, so that we can see this practically. So one of the terms that's very important is pod. So a pod is a collection of multiple containers. So potentially a pod can contain multiple containers. In this case, we have one container per pod. And when you have to implement scalability, like when you have to use load balancing and auto failover or self-healing, it will basically end up scaling out the system. So it will basically create multiple identical pods for us. So a pod is the smallest unit of work in Kubernetes. Usually a container is the smallest unit when you use Docker, but in case of Kubernetes, pod becomes the smallest unit. So a pod is sort of a process that runs your container. And pod is specifically available when you use Kubernetes. It's not available without Kubernetes. Like if you just use Docker container, there will be no pod at all. You will just have the container. But when you use Kubernetes, it will encapsulate the container inside a pod, which basically acts as a process which offers load balancing, service discovery, auto failover, self-healing sort of functionalities, and so on. So keeping this concept in mind that we usually have pods in Kubernetes, and whenever we have to implement load balancing and auto failover, we basically get to scale out our pods. So keeping this in mind, let's see things practically. So first of all, I'll show you how we can build our application that will be composed of three sort of projects. We will have this REST API for authenticating the user. We will have another REST API that will be responsible for providing some data services. Here, I do not have all read-write sort of functionalities. I just have a very simple login sort of scenario. So basically, a user will be able to register. So registration request will be sent, and user will be able to get registered, and the registration information will be stored just in the memory. I'm not using any database in this particular scenario. So basically, we will have three applications, and we will see how we can build three separate Docker images. So one image per microservice will be created, and then after that, we will deploy our application. All these microservices will be deployed to Kubernetes. So let's see this practically. And usually, most of these steps are fairly time-consuming, like downloading Docker images, customizing them, saving them, takes quite a bit of time, and even starting up Kubernetes takes time as well. It takes at least 6 to 7 minutes, and at times when you don't have sufficient resources, it times out. So what I've done is I've pre-recorded my demo. You'll be able to watch the recorded session later on as well. So let me open up my first demo here. So this will be basically for explaining how we can deploy a multi-container application to Kubernetes. And I'll show you all the things step by step, like how we can build Docker images first. Then we will see how to deploy them to Kubernetes as well, and so on. Now, when it comes to using Kubernetes, there are various ways in which you can use Kubernetes. You can choose to install Kubernetes. Just Google for where exactly Kubernetes is located. It's developed by Google. You can download it from there. And you can use kubeadm, kube administration command, and kubectl commands. And then you have to set up your Kubernetes cluster. So a Kubernetes cluster basically means that you can have multiple machines. So let's say we have machine number 1. This will act as the master. So we have, let's say, the master instance here, and then you can have multiple instances or multiple other nodes here. So let's say this is node number 1, and you can basically create multiple copies of this one. So we have node number 1 and node number 2. So basically, master will be connected to multiple nodes, and each instance, like even the master and all the nodes as well, they will be able to host our application in the form of pods, and each pod will basically contain a Docker container. So this is basically a Kubernetes cluster. So you can have a multi-machine setup if you want, but that can be fairly time-consuming. So here I'm just going to use a single machine setup for now. We'll just have the master basically. We will not have these separate nodes. Back in the day, Kubernetes used to call these nodes as minions. So you might hear this term when you Google for Kubernetes and so on, that these nodes are also called minions, but the modern term for minions is just node. So here I'm just going to use a single machine setup. And even this setup can be performed in various ways. You can choose to use just the raw or regular Kubernetes files like kubeadm, kubectl, etc., and so on, or you can choose to use some pre-packaged solution. So Kubernetes comes in various pre-packaged sort of solutions. Like there's a solution called Minikube. So Minikube is a pre-packaged sort of installer. It contains Kubernetes. So when you use Minikube, it essentially sets up Kubernetes for you with ease. So just to simplify the setup, you can choose to use Minikube, or if you want to use a more enterprise approach, you can choose to use Red Hat's OpenShift. OpenShift is fairly complex. It contains well over 400 different services. Like it contains edge services, it contains lots of other services as well, and so on. We do have courses on OpenShift and so on. So for now, I'm going to use Minikube since that's one of the simplest possible pre-packaged solutions when it comes to using Kubernetes. So I have a Kubernetes setup here, and we have to start it up first. So to start up Kubernetes or the Minikube, which is essentially the same thing, first of all, you can choose to use Minikube status to see if your Kubernetes cluster is up and running or not. It's not running, so we are going to start it up by using Minikube start command. And usually it takes about 6 to 7 minutes or so, and if you don't have sufficient resources, it usually times out. But fortunately, I've already recorded my demo, so I've edited the videos so that I can speed things up. So here it just took about 2 to 3 seconds or so, but in reality, it takes about 6 to 7 minutes or so. And if you don't have sufficient resources, it will time out. You will have to run this command 2 to 3 times before it will eventually start up the Kubernetes cluster. So once you have Kubernetes up and running, if you get the status again, it will tell you that yes, this time around it is up and running. You can see the IP address of your cluster as well. Then after that, let's go to our workspace folder where we have our projects. So here I have 3 separate projects. We have the Authentication API, we have Data API, and we have our front end, the React-based application. So again, as a reminder, this React application will connect to this Authentication API. It will receive a token. After that, React application will be able to connect to this data API, but it does have to send the token as part of each request to this data API. And internally, this data API will check with the Authentication API whether the token is valid or not, and so on. So we have 3 separate folders here. Each folder contains a separate microservice. So first of all, let's focus on our Authentication API. It's a simple Java-based application. I'm using Gradle as the build engine here. So here, our focus will not be on the source code itself. We have separate courses where we discuss how to develop the application from scratch. More importantly, we have to see how to build this application and ensure that the artifacts, the deployable artifacts, they're contained in a Docker image. We do have Docker file as well, the script that we will use to build our Docker image. This is how a Docker file looks like. This is a slightly more real-world way of building our Docker images. And notice that in this particular Docker file, we have 2 from keywords. When you use multiple from keywords, it becomes a multi-stage build. So previously, in the very first Docker demo, I had a single from keyword, but this time around, we have 2 from keywords. And it's a multi-stage build. What's the meaning of multi-stage build? So multi-stage build basically means, say you have some central server where you have, let's say, Git repository. And you have some development machine, or actually, let's say that it's your build agent. So most companies prefer automating their builds. They use some automation solutions such as Jenkins or some other solution like TeamCity or Travis CI, etc., and so on. And they perform the build on a dedicated machine, which is known as a build agent. So on this build agent machine, we are going to create a cloned copy of this repository. So this is our remote repository, the central repository. And on this build agent, we will check out the contents of this, or create a cloned copy of this repository. It will be available here. And then on this build agent, we are you can definitely choose to install JDK. You can install Gradle. You can install all possible tools if you want, all your compilers, etc., and so on. Or you can say that, no, we want to keep this build agent machine as simple as possible. There's next to nothing here at all. So how do you build your application now? How do you compile your application? So for that, you can use Docker. So you can create a Docker image here that will be sort of a temporary image, or to be more precise, let's just call it Docker container. So you can create a container, and you can customize this container, install all your development tools like JDK, Gradle, or Maven, etc., and so on, Spring Boot, and so on. So you can install every possible dependency here in this container. And the purpose of this first Docker container on this build agent will be just to perform the build. So this is a single machine, basically. Let me try it again. So basically, it's a single machine. And here, we have this Docker container, and its only responsibility is to perform the build. That's it. And generate the deployable artifacts, like your jar files, etc., and so on. So it's sort of a just the container meant for build purpose. And after that, we want to make sure that we copy the artifacts from this particular Docker container into another container. This is container number 2, and this container will be meant for hosting our application or containing our application for deployment purpose. So this is the actual Docker container that we want to deploy to Kubernetes later on. And this will basically obtain the artifacts from the first container. So the first container is only meant for build purpose. It will generate the deployable artifacts, and the second container will basically copy over the file from the first container. And after that, this container will be useless to us. It will be deleted. We will just keep this one so that we can later on deploy to Kubernetes. And what's the benefit of using this first container? We basically want to make sure that none of the dependencies, none of the development tools, they should be installed on this build agent. We want to keep this build agent totally independent of our development tools, etc., and so on. Like in future, if you lose this build agent machine, if it's crashed, then we should not be responsible for reinstalling everything from scratch. All the development tools, etc., and so on from scratch should not be installed. So for that, we want to keep this build agent machine totally independent of this particular sort of development tools and so on. So that's why we want to containerize our build as well. So even the build process will be containerized. So here we have two stages. So this is known as a multi-stage build, where we have two stages. So keeping this in mind, we have two from keywords here. So the first from keyword corresponds to the first Docker container, which will use this base image. Again, you can go to Docker Registry, which is hub.docker.com. You'll be able to search for it. So this one already contains Gradle and JDK 10. And we're choosing to assign it this alias as builder is the alias. You can name it whatever you want. Alias is useful so that the second stage should be able to refer to it. And then after that, we are using Gradle. We are performing the build. Or if you're using Maven, you can use mvn command to perform the build. So the first container or this particular Docker container will just be responsible for performing the build. And after that, the second stage will utilize JDK 8, or you can use whatever version you want. It's totally up to you. And we want to make sure that it copies over the deployable artifacts from the first container. For that, we're using copy command from, and here we are specifying the alias of the first container. So basically, it will copy over the artifacts from the first container into the second container. And then here we are specifying exactly what port number should be used by our application so that later on when you deploy it to Kubernetes, you should be able to access this particular REST service and so on. And then we are running our application. This is a Spring Boot-based application, and we are running our application like this. So entry point allows us to execute our application. So basically, this is our Docker file script that will be responsible just for building our first project, which is our Authentication API. So keeping this in mind, let's execute this particular script. So for that, we have already seen this Docker build command previously. So I'm giving my custom image this name, project authentication, version whatever. Dot means in the current folder, it will find Docker file, and it will perform the build. So here we can see that it's downloading Gradle, JDK 8, and in real world, it does take about 5 to 6 minutes at least. So here we have download JDK with Gradle. We have performed the build. So notice that Gradle is getting executed here. And then after that, we want to work on the second stage, which will basically utilize JDK runtime only, and it will just execute our Spring Boot application. So at this point, it is not running our application. It is just creating the image, just the blueprint, just the template. And later on, we will deploy this image to Kubernetes. So once we are done building our image for the first microservice, next, we can verify that we do have a custom image. So if you use Docker images command, it will tell you that, yes, we have this custom image, project authentication. Next, let's look at the second project, the second microservice, which is our data API. So again, it has its own folder structure. It's also a Java-based application. Again, we are going to use Gradle to perform the build, and it will be a containerized build. It has its own Docker file as well. So if you look at Docker file of this particular project, again, you can see that it's a multi-stage build. So here we have the first stage, which will be responsible for building the application. It will use Gradle to perform the build, and then it will copy over the artifacts into the second container. And once we have performed the build for this one as well, again, you can verify that the second image is also available. So you can use Docker images command again, just filter it out, say that you want to see if this project data is available or not. Next, let's deploy these to Kubernetes. So again, if you recall, we discussed that Kubernetes is a container orchestration solution, which means that it lets us deploy our Docker images in a more advanced manner. Advanced manner means that usually Docker container, it's just useful to create a portable application. But other than that, it doesn't really offer any other service at all. So if you want to have access to other advanced services like load balancing, auto failover, service discovery, etc., and so on, so that all these containers can communicate with each other. If one goes down, there should be some other identical instance available to us and so on. So to ensure that we can manage our applications, orchestrate our applications or containers in a more professional manner, we are using Kubernetes here. And to deploy your Docker images to Kubernetes, we can use kubectl command, run, and then specify the base image, which is this one. And we want to name our pod. So this will basically end up creating a pod for us. Again, a pod will basically contain a running instance or a container based on this image. So we are naming it project auth. So basically, this is how we deploy our Docker image to Kubernetes. So once you're done deploying it, you can choose to get your deployment list. Ignore this node application. I usually use it for some other demos or courses. So we are just going to focus on this project auth here. So we have deployed our custom Docker image, which contains this Authentication API. So once we are done deploying the first microservice, next we can check or deploy the second one as well. Or actually, before we deploy the second one, let's make sure that whatever service is there in this particular deployment, it's exposed, it's available to us. So we want to make sure that the service that is running inside this particular pod or container, it's not just sort of an isolated service. It should be exposed, it should be available to other containers, to other pods in this Kubernetes cluster. So just so that we can have service discovery in place, we're going to use this kubectl expose command. So when you use this command, you'll be able to specify what port number you want to utilize. So you can say that internally, as developers, we have used port number 8081. But when you expose it to other containers, you want to change the port number to something else. So you can choose to change your port number if you want. It's optional, it's not mandatory. So here we are saying that the internal port number is 8081, but it should be available to other containers as port number 9091. Basically, we have done it for our first service. So the service is exposed. We can verify the service is exposed by using kubectl get services command. It will tell us that we have this project auth, and this is the IP address assigned to this particular pod, and this is the internal port number. And in case if you want to access it from outside the cluster, like this is inside the cluster. So inside the cluster, usually your port numbers, your IP addresses, they will be private. But in case if you want to access it from outside the cluster, like from other machine, like remote machine and so on, for that it generates this public sort of port number as well. So if you want to access it publicly, you'll want to use this auto-generate port number. If you want to access it internally only, you'll want to use this 9091 port number. You don't always have to generate public port number. You can choose to disable it if you want. For now, we are just going to use the default option. Next, we need to do the exact same thing with our data service. So we have already deployed our it's actually here, the kubectl run command. This will basically deploy our data service as well, or data microservice. And once we are done deploying our service, you can verify that you do have the second deployment, which contains our project data microservice, which is responsible for providing data services. Like you can retrieve a user list, you can add more user accounts, you can remove them, etc. and so on. And then you can also expose a service for this one as well. Again, when you use kubectl get services command, it's essentially providing us with service discovery functionality, which means that other containers will be able to connect to it. So when you use kubectl get services, it will not show you the service for this one right away. You do have to expose it manually. So for that, you have to use kubectl expose command. Again, the internal port number which we have used as developers is 8080, but when it's available to other containers, we want to make sure that it's available as 9090. So you can choose to change your port mappings if you want. It's optional, it's not mandatory. And once you're done exposing your service, you can get the services again. Notice that we have both these services available, the authentication service as well as the data service. And now you'll want to make a note of these IP addresses that have been assigned to these pods, because our React application will have to connect to these. So React application, which is our front-end application, will use these IP addresses and these port numbers as well, like 9090, 9091, and so on. So make a note of these IP addresses. And then next we need to go to our React application and open the configuration file which we have created just for this React application. Here we need to specify where exactly our API service, the REST API, and our account service. Account is basically going to connect to this data API / account is mapped to this particular service, and / API is mapped to this authentication service. So we have to make sure that we specify the IP addresses and the port numbers which we have obtained from our Kubernetes cluster. So, make sure that you specify the IP addresses and also change the port numbers as well. So make sure that it's 9090, 9091, whatever we have exposed these services as. So whatever port numbers you have assigned, make sure that you specify them here. And in advanced scenarios, in case if you have configured proxy, which is not the main scope of this particular session, you can choose to set a proxy as well, so that you can make things more secure and go over a different network, etc. and so on. So for that, you need to modify one more file as well, which is set up proxy. So now we can actually skip it. So basically, once you have customized your configuration file for the React application, which now contains the IP addresses and the port numbers of these two REST APIs, next we can build the Docker image for this one, and we can deploy it to Kubernetes. So for that, we can use Docker build again. It will execute the Docker file of our front-end application. It's a React application, and it will be deployed to a web server. Here, as a case study, I'm using Nginx. It's an open source web server where I'll deploy my React application. Basically, I'm using Nginx here, and it will host our React application inside a container. So for now, we are just creating the image for this front-end application. And once we are done with this one as well, next we can deploy it to Kubernetes. So for that, we can use kubectl run command again, specify our image name for the React application. And once we are done with this thing, you can expose the service for this one as well. So let's expose the service for this one as well, so that we can access it from outside our cluster. And in case if internally inside the cluster it's required as well, it should be available to other containers and so on. So in this case, we are going to use the IP address and the port number which has been assigned here. So make sure that you obtain the public IP address. So usually your REST services will only be accessible by your front-end application, but this front-end application will be accessed from outside of this cluster. Like end users will be using their own machine, and they will want to connect to this React client. So that's why you have to make sure that you do not use the internal port number, you use the external or the public exposed port number. So the publicly exposed port number in this case is this one. You can always customize it if you want. For now, we are just going to use the auto-generated port number. So make sure that you make a note of this particular port number, and then next we can type in the IP address and the port number that has been assigned to our React application, the front-end application, and we can see this simple user interface. So here we can enter some credentials, or we can just register for a new account. Click register, enter username, password, click register, and the moment you click register, since at this point we are sort of an anonymous user, we are not a logged in user, so it will connect to this data API and will register a new account. So we have registered for a new account. After that, you can just perform other operations if you want and so on. So basically, even though the front-end application is fairly straightforward here, the user interface is very straightforward, but internally, it is using lots of concepts like microservices, Docker containers, Kubernetes, etc. and so on. And Kubernetes is making sure that we have service discovery, and we should also be able to implement load balancing and auto failover. And talking about load balancing and auto failover, let's actually do that. So currently we have just one instance per deployment. So deployment means all these are separate images. So each image is considered as a deployment. So currently we have just one instance of each deployment. So in case if there's too much load on the system, then there will be no load balancing at all. And there will be no auto failover. So users will get disconnected if the instance has crashed. So to ensure that even if there's any failure, like if nothing else, you could have some runtime exception, like maybe some exception got thrown and you haven't handled it, you haven't caught it. So even that can result in the failure of your application. So to ensure that if there's any failure, it should fix that failure in a sense that it should start up another identical container so that users are always able to connect to your application. You need to make sure that you scale out your application. So scalability wise, you can choose to manually scale it out. So to manually scale it out, you can execute this command. It's this one, kubectl scale, specify the deployment which you want to scale out. So we want to scale out our authentication API. We want to have 3 identical replicas. So it has been scaled out. So you can choose to manually scale out like this, or you can also choose to automatically scale it out as well. For automatic scaling, you can specify various factors like CPU utilization, memory consumption, and so on. So in the full-blown courses, we talk about how we can automatically scale out the parts or the containers as well. For now, just know that you can scale out based on the CPU consumption and the memory consumption as well. And it's up to you. You can choose to scale out all of them or just one of them. It all depends on what application or microservice will be the busiest one. It will have most load on it. So depending on how much load each service will have, you can scale them out separately. So for now, we are just going to scale all of them out. So we have 3 identical instances of each microservice. And you can use this kubectl get deployments command again. It's telling us that we do have 3 replicas of these microservices. And it does take a bit of time, like at least 3 to 4 seconds for the memory intensive resources. Like in this case, React is not scaled out right away. But if you run the command again after a few seconds, it will tell you that it is 3 out of 3. So it does take a bit of time to scale out the resources. It all depends on how heavy it is, like how much memory is required, how much CPU utilization will be there for that particular resource, and so on. So basically, if you get the part list this time around, previously we had just 3 parts. So there was a part for Authentication API, a part for Data API, and a part for frontend. But this time around, we have 3 parts per microservice. So if any part crashes, we still have 2 additional parts available. And it will ensure that it automatically starts up another identical part so that it always keeps it as 3. So that's the beauty of Kubernetes, that it has self-healing capability, which means that if a part has crashed, if a service has crashed, it starts up another identical instance. So if, as an example, if you just copy any part name here and you purposefully fail it. So for now, I'm just going to use kubectl delete command. I'm just going to forcefully delete a part. So even though I've deleted this part, it's deleted, but if you get the part list again, it will tell you that you still have 3 parts. So all these services, they still have 3 parts each, because Kubernetes has self-healing capability. It automatically starts up another identical part. Since we have said that it should be scaled out to 3, it will always keep it as 3. So that's the beauty of Kubernetes, that it's not just auto failover, it is more than that. It is self-healing as well. So basically, that's how you can deploy a multi-container application. You can scale it out, and after that, you can choose to delete your resources if you want. So here we are just deleting our services and all the deployments and so on. All the images have been deleted from the Kubernetes cluster. Okay, so any question regarding this concept so far before I talk about logging and monitoring concepts as well? And yes, you guys will be able to access the recorded video. So once we are done with the session, it will take a few days to process the video, and eventually it will be uploaded and you will be notified once the video is available. And you do have the PDF files available, the slides in the chat window. Okay, any questions so far regarding this part before I talk about logging? Okay, so here we have seen how we can deploy a multi-container application. Before that, we saw how to build a Docker image for each microservice. Then we saw how to deploy it to Kubernetes. Then we also discussed how we can scale it out as well. That does offer self-healing capabilities as well. Then next, let's discuss the last topic, which is about logging and monitoring, and actually also about tracing. So chapter number 3 in the PDF file is about logging monitoring. Okay, so since we don't have too much time, so let me just keep it as practical as possible. I'll explain all these concepts in the demo. So basically, logging, or before logging, let's talk about monitoring, since that's relatively more straightforward. Once you have deployed your application, ideally we should monitor it. We should check the RAM consumption, CPU utilization, etc. and so on. So to monitor your application, you can use various tools. One of the most popular options is to use something called Prometheus. Prometheus is an open source solution for monitoring your applications. And although it can be used with pretty much any type of application, but here as a case study, I'm going to use the same Spring Boot sort of a scenario. I will have a Spring Boot application, and I'll show you how we can integrate or how we can configure monitoring capabilities in our existing Spring Boot application. So you can have pretty much any Spring Boot application and you can enable monitoring in it. And what exactly will happen? So monitoring wise, we will basically end up having a Spring Boot application. We will enable monitoring in it. And once you're done with it, it will be able to expose its metrics, like what's the CPU utilization, what's the RAM utilization, etc., and so on, to Prometheus. So Prometheus will be able to connect to our Spring Boot application, only to that Spring Boot application where we have enabled the Prometheus feature. And what we will do is that we will run Prometheus in a Docker container, since we want to make sure that we have next to no dependency on the operating system or on the machine. So we will run Prometheus in a Docker container. And this Docker container can be deployed to Kubernetes. So in fact, if we have the same scenario, you can choose to have Prometheus running in a different pod that will run Prometheus. So we have another pod here that will run Prometheus. And all these pods, they can choose to connect to this Prometheus or expose their metrics to Prometheus. So this way we can use Prometheus to monitor all our applications that are running in our Kubernetes environment. And when you use Prometheus like this, where multiple pods will be sort of exposing their metrics to Prometheus, this sort of acts as a sidecar. So a sidecar container is a term used for any container that is available to other containers, and most containers will end up connecting to that particular container to log something or to expose the metrics, etc., and so on. So we're going to use Prometheus as a sidecar container in this particular example. And there's one more important concept here. Since we are taking a Spring Boot application as a case study application, so Spring Boot offers something called Actuator. The Spring Boot Actuator is a feature of Spring Boot applications that exposes its functionalities or its metrics to other applications like Prometheus, etc., and so on. So we will have to make sure that we configure our Spring Boot application so that it uses Spring Boot Actuator to expose its metrics and so on. And we definitely have to make sure that we configure Prometheus as well in our application. So keeping this in mind, let's see this practically here. Let me open up my second demo here, monitoring with Prometheus. Okay, so in this case, I'm going to use another application just so that I can keep things a little simple here. I've opted to go for a simple standalone application. It's also a Java Spring Boot application. I'm using Gradle as a build engine. You can choose to use Maven if you want. Let's look at our build.gradle file. Here we just have Spring Boot dependencies added at this point. I've commented out some of these dependencies. I'll talk about these in just a bit. So here we just have Spring Boot version 2 basically. So at this point, we don't have anything special in our Gradle build file. Let's look at our controller, the REST API. It's a very straightforward REST API. This is just the simple controller which basically has this particular get mapping. So if you access this /employees URL, it will basically return us the list of employees and so on. And if you look at the data access object of this particular application, we have 3 hard-coded records in this particular case. So REST API will basically return the list of these records. That's it. It's a very straightforward Spring Boot application. When you type in /employees as part of the URL, it will basically show us the list of employees and so on. Let's test this application in sort of a standalone manner without using Prometheus whatsoever. So for now, we just want to see what this basic application is before we add Prometheus functionalities to it. So for that, we can use Gradle, we can use boot run. It will start up the built-in server. Or if you're using Maven, you can use MVN, Spring Boot -run. So basically, Spring Boot will start up its own built-in server. The application is hosted. And if you access this particular site by using the default port number, which is 8080, and you type in your URL or this /employees, which I showed you in my controller, this is basically going to return the list of employees. We have 3 hard-coded employees here in the simple REST API. More importantly, we have to see how to enable monitoring. So currently we have a simple Spring Boot application. It can be any type of existing Spring Boot application. And to enable monitoring functionalities by using Prometheus, you have to make sure that you edit the build.gradle file, or in case of Maven, you have to open your pom.xml file and ensure that you add a couple of dependencies. So dependency number 1 is Spring Boot Starter Actuator, which will basically enable the feature that will let the Spring Boot application expose its metrics to Prometheus, etc. and so on. And in order to use Prometheus, you have to include this particular dependency as well. So micrometer, registry, Prometheus. So add these 2 dependencies, and after that, you have to do one more thing. Or first of all, let me just run this application again and show you without Prometheus how it looks like. So when you enable or when you add Spring Boot Actuator, all your Spring Boot applications where you have added Spring Boot Actuator, they will let you access this /actuator URL. So you have to ensure that you add /actuator immediately after your domain name and port number. So this /actuator will show you some default metrics. Most of these default metrics are not really very good. To make these more useful, you'll want to add Prometheus. So let's ensure that we add Prometheus as well, so that we can see some more metrics that are getting exposed to other tools and so on. So let's include Prometheus functionality as well. So for that, you have to make sure that to your Spring Boot application, you add some configuration. So you can go to your resources folder, go to your application.properties, or you can go to your application.yaml file and ensure that you add settings like these. So here we are basically ensuring that Prometheus should be enabled. So Prometheus should be able to gather metrics from this particular Spring Boot application. And we are choosing to expose all the endpoints, all the services that we have in our Spring Boot application so that they can be monitored by Prometheus. So once you have added this configuration to your Spring Boot application, after that, if you build your application again, start it up again, this time around, you'll be able to see some more exposed metrics here. So if you access /actuator, it will show you Prometheus as well. So it's somewhere here. Scroll down a little bit. So we have Prometheus available here. And when you type in /Prometheus as part of the URL, it will show you lots of useful metrics that you can monitor. Like we can monitor RAM consumption, CPU utilization, CPU uptime, and there are lots of them. So it's a huge list of useful metrics that you can monitor. Now, question is, how exactly do you use these metrics? So right now they are just getting exposed, but we are not consuming these. To consume these, to capture these, to visualize these, we need to use Prometheus. So right now, although it's configured in our project, it's exposed, but it's not getting consumed. So to consume it, we have to make sure that we start up Prometheus. So you can choose to run Prometheus by installing it on your actual machine, or you can choose to run it in a Docker container that you can deploy to Kubernetes. Like I mentioned that you can have a Sidecar container. I think I explained it here. So you can have a Sidecar container where you have Prometheus running, and it's also part of your Kubernetes cluster. So that's exactly what I'll do here. I'll run Prometheus in a Docker container. But before we do that, we need to make sure that we obtain the IP address of this machine where our Spring Boot application is running, so that when Prometheus runs, it should know where exactly your applications are located, so that it can gather the metrics from it. So for that purpose, you have to make sure you obtain the IP address of your machine where your Spring Boot application will run, or if you have Kubernetes, you'll want to obtain the IP address of your pod where your application is running. So make a note of your IP address and then create a configuration file. You can name the file whatever you want, store it wherever you want. For now, we are naming it Prometheus.yaml, and ensure that the configuration looks like this. You just have to make sure that you change this last statement, which is targets. So make sure that whatever IP address you have noted in the previous step, you write it down here. And next, we are going to run Prometheus and pass it the configuration file. So it should know where exactly the applications are running so that it can connect to those applications and obtain the exposed metrics and so on. So here we are going to run Prometheus as a sidecar container. So we're going to use Docker run for now, but you can definitely choose to use kubectl command, Kubernetes command to run it on your Kubernetes cluster if you want. So for now, we are running it like this, and then it's basically going to consume or utilize our configuration file, Prometheus.yaml. And once this is done, once your Prometheus container is up and running, you can connect to it. So if you recall, here we used port number 9090 when I used Docker run command. So we have to access this particular URL in our web browser. So this is the Prometheus front end. And now we can specify the metrics that we want to monitor. So whatever Spring Boot application we have configured it to expose its metrics. And now we can consume these metrics here. We can visualize these metrics here. And there are lots of metrics here. Like if you recall, in this particular tab, we have lots of metrics showing up. So you can copy pretty much any metrics and enter it in your Prometheus user interface. So let's say that we monitored process uptime for how many seconds the Spring Boot application has been up and running. So you can type in process uptime, you can click execute, it will show you the time here in seconds, and you can also choose to look at the graph as well if you want. Likewise, you can choose to monitor something else, like let's say a CPU or a system CPU usage, etc. and so on. You can also monitor RAM consumption as well and so on. So basically, all these metrics are getting exposed. They have all been configured in our Spring Boot application, and Prometheus is now able to monitor them. Hello, can you guys hear me? I think Zoom just froze up for a bit. Okay, let's continue. So basically, we are monitoring our metrics. You can also monitor something else, like let's say we monitor how many times our REST service has been accessed with get method, and the status code has been 200, which means everything was okay, nothing failed. So basically, we want to make sure that all status code 200 get method-based requests for this /employee service, we see the count here, how many times we have sent the request to that particular service and so on. If you execute this one, it will show you the metrics here and so on. So if you refresh your service or access the service a few more times, you can access the count here, it will show you the value here and so on. So in a nutshell, Prometheus is a monitoring tool that you can use to monitor pretty much any type of application that has the ability to expose its metrics. And you can enable this functionality in pretty much any major technology like Node.js, .NET Core, Spring Boot, etc. and so on. And Prometheus will be able to connect to that particular application, monitor its metrics, etc., and so on. Okay, so any question regarding monitoring part before I talk about tracing as well? Okay, so next let's talk about tracing. So since we have a REST service here, you can choose to trace it. So tracing means each time a service is accessed, whether it is get method, post method, put method, delete method, you want to trace all these activities. So you want to find out how much time it took to execute the service, what was the status code, and in case if you have a complex service, like if a service depends on some other service, so they are nested or chained calls, then you're also able to see the entire trace. So if you want to see all your historical REST service accesses and your entire trace as well, for that you can use various options. One of the most popular options is called Jaeger. So Jaeger is an open source solution that allows you to trace your applications. So Jaeger, we will use this one in just a bit. Again, it will basically connect to our Spring Boot application. It will record all the historical information, or it's actually the other way around. The Spring Boot application, as developers, you will be responsible for writing some code here that should send its information, the traces, to this Jaeger. So you'll want to basically send the information to Jaeger. Okay, so let's see how we can use our this tracing concept with Jaeger, so that we can keep track of how many times a service has been accessed, what was the status code, and in case if they are nested or chained calls, then we should be able to get the information regarding that as well. So for that, we can go to our application. Let me actually open up this third demo here regarding tracing.